Is it moving now?
Yes, yes,
Yes,
it is.
Manoj. Yes, Manoj. Yeah.
Okay. So sorry about some technical errors. Laser Science Services is the pioneer in distribution of a diverse range of the lasers and related equipment which cater to the industrial manufacturing and the scientific research in India. Founded in year 1988 by Dr. Lalit Kumar, Laser Science today represents 20 plus leading laser manufacturers from all over the globe, covering a wide range of the products which include the scientific and the industrial laser system for spectroscopy, microscopy equipment, and imaging system. So today's agenda is basically is on the DD and the SLM benefits and its principle, the market size of the additive manufacturing, brief of the additive manufacturing system developed by the laser science team, various application of the DD and SLM in defense and medical industries. To start with the additive manufacturing, one should understand what is the process. So there are various process of the additive manufacturing like liquid based process and the solid based. So today we are going to focus only on the solid based process, which is having a powder based mainly, where the melting is to be done with the help of the laser. In powder bed fusion, the melting is taken by the laser, but it is called as an SLS or SLM, that is selective laser melting procedure. In direct energy deposition, the laser energy is being used to melt the powders. Hence, it is called direct energy deposition method. Now, other processes are also very popular, like polymerization, object bonding, molten. But these are various used for the various other application, which is catered to a non-metal. Now, what is the process of the direct energy deposition or any SLM process? So to start with, first we have to design some 3D model to develop a various 3D design by using a CAD. Now this CAD model need to be sliced in number of layers using various softwares and convert this into an .stl file. This is very important to process this slicing with the help of the software because it reduces the lot of programming work. How the 3D printing, the printing is taking place. So this file need to be transferred and positioned, and the printing of the design is being done by layer. This finishes our printing parts, and next part is to do the post processing. Now you have a question, why the post processing? The post processing only because the parts which is printed may not be as per the surface finish or as per the dimension required by you. So there are a lot of chances of the errors are always there when we do any 3D printing parts. So most of the time these parts are printed on a base metal which is having some legs or some supports which is need to be eliminated. So post processing is important. After doing that, the final product is what you receive in your hand is a final 3D printed product. So coming to a direct energy deposition principle, uh, type of a 3D printing or additive manufacturing process, the basic principle remain very simple, that from the center, the laser beam is passed and the powders are passed through a nozzle from both the side, which is called as a coaxial nozzle. Now this laser will straightly focus on the substrate in such a way that the deposition of the material will be done layer by layer. So this way, simultaneously with the nozzle, you will able to deposit the powder which is there in the nozzle on the substrate. Similarly, another principle of the DED system where we use a wire beam, the wire is fed from the side and the laser is coming from the center. Similar way, the laser is focused at the substrate where the wire is being deposited layer by layer. So this is a very basic, simple principle of the direct energy deposition where any person can able to operate this simple mechanism. Now, when we come to the powder-based 3D printing principle, it is different from the DED principle, where ytterbium fiber laser is been focused through a focusing lens, and there is a beam steering system called galvo scanner is kept. The purpose of this galvo scanner, whatever the .stl file which is converted into layer by layer, is been transferred into the right angle and at the right focus with the help of the focusing lens. Now this laser has been transformed on a bed which is having a full of the powder bed. It is called a powder bed chamber. Now this chamber is full of the powder initially, and there is a layer by layer the roller or the coater from left side to right side or from right side to left side has been moved so that this powder has been transformed in a uniform layer. If we do not use this coater or a roller, there is a chances that the powders are become uneven. So if you see the left hand side of the coater, the uneven powders are there, which is with the help of a coater is formed in a uniform way. Around the layer by layer, the powder bed chamber goes up and the top surface of the powder is transformed into solid metal part. So what exactly the powder based and the wire based systems are made of? Exactly, when we talk about the powder based system, you need the laser engineering or a beam shaping process or the finalization of the laser beam, which is having a beam with the help of a various focusing lens deposited at the right spot. And this process is also called as the direct metal deposition process. In wire-based system, the variable feeding of the various type of the wire-based systems are available, and you can use either the laser or you can use a TIG or MIG welding system also to use the wire-based system, because sometimes the diameter of the wires are so high. So other than laser, another type of the technologies also are used for making the 3D printing solutions. When we talk about the parameters of the laser DED system, various parameters which is important in case of selection of the lasers are like power, then beam diameter, the beam profile, working distance, and the wavelength. The next parameter important is the type of the nozzle selection, whether you want to use a coaxial nozzle or four-way nozzle, the feed rate of the powder through this nozzle, the feed rate of the carrier case, which is responsible to feed the powder from the powder feeder to the nozzle, is also very important. Material and design. What are the type of the powders you want to use? That is very important. What is the diameter and distribution of the powder? That is also important. The shape of the powder, whether it is spherical or circular. The material substrate which is you are going to use, whether it is finished or whether it is hardened or a soft surface. So that selection is also important, and the geometry is also very, very important. When we talk about the motion path, the scanning speed in case of the SLM is very important. Again, important factors in certain cases, you need to have a preheating of the temperature, like certain melting point of the powders or the substrates are not suitable for the laser or any other application, where we use a induction technology to preheat this substrate so that the molten powder layer by layer easily spread on the substrate. What is the deposition path? That is also very important. Like you are moving at a very high speed, and all of a sudden there are some curvatures or some uneven surfaces required to be deposited this layer. The deposition path selection, track overlap ratio, these are all various points we need to consider in the case of the motion and path. Like if you want to compare what the two technologies are used, when one should use the laser power bed fusion and when one should use the direct energy deposition. So there is a lot of arguments or a lot of comparisons are available. So few comparison I have highlighted here out of that is like when you select the laser power of the laser powder bed fusion, the power available is 250 watt up to 1000 watt. That means you don't have a very high energy compared to the DED where you have a more than 8000 watt also. Then when we talk about the building rates volume, the building rate, low build rate volume, you can do with the help of a laser powder bed fusion 0.5, 0.15 kg per hour. And when you talk about the DED, it is a high build rate volume up to 7 kg per hour. Build volume small to medium, like you can able to design the smallest parts around 150 diameter, in which a lot of other components of a tiny pin to the big uh, parts also can be printed with the LPBF. But in the laser direct energy deposition, you can able to print medium to large size part, that is 150 up to 2000 millimeter or 3000 millimeter also now available. Multiple material, whether you want to use a single material or a multiple. So in case of the LPBF, only a single materials can be used, which is filled in the powder bed chamber. Whereas in the case of the DED, since we are using a nozzle to deliver the powder, either we can use a dual powder feeder or you can also have a four-way nozzle with the dual powder feeding. So these are the various methods you can able to use different bimetal powders in case of DED. When we talk about the repair of the existing parts, whether LPBF can able to do it, so the chances with the LPBF is very limited to use the repair of the additive material parts. Whereas in case of the DED, you can also able to repair the existing part which is damaged due to corrosion or a chemical erosion. Now, what are the materials or the powder in the additive manufacturing systems available today? So today, a lot of powder manufacturer company, even in India, are available with the iron-based solutions where you can use a stainless steel parts like SS316L, SS420, tool steel grade parts and powders are available, and the parts can be printed out of these powders. In nickel base, there are various options available in Inconel 625 or in Inconel 718, or there are HANES 214 or 282. So various types of the nickel based powders. Monal K is also sometimes is been used in the case of the aerospace industry. So these are the various powders available, which is having their own advantage of the lightweightness and the strength. Copper base also powders are sometimes available, depend upon the application to application, and similarly aluminum and the cobalt base is also used. COCR is very popular in the dental industry for manufacturing the dental caps. Stellite is used for the engine wall and the turbine blade, and the bimetallic materials also available like GRCOP or C18150. These are various standard companies like Hoganus is there, Metco Sulzer. They are the international companies manufacturing the powders for the additive manufacturing. Now, why we are into this webinar and why one need to study the additive manufacturing industry today? So today, when we see this pie chart is giving you a very fair idea why one should have a additive manufacturing in industry growing at a very high rate. So when you can see the motor vehicle, the automotive industry is the major chunk where the additive major technology is already used, more than 32%. Then we also have a medical application around 9%. And then we have a very big, if you consider government, military, and the aerospace together, there is almost 15% is been additive manufacturing method is being used today for developing various parts for the defense and the aerospace sector. Also in consumer products, 18% parts are used, but that is mainly for the non-metal or a polymer-based additive manufacturing. If we see this analysis further, the growing rate of the 3D printing technology in the global market, you can see it is almost reaching a value of 107 billion by 2031, representing a compound annual growth rate, CAGR. It is almost a 21.9% CAGR. And today, the manufacturing sector, if you see, and the aerospace and defense sector, it already started picking up from 2021 to 31. The growth rate is very high. In India, the 3D printing market is stood at almost the US dollar 92.34 million in 2022, and it is forecasted to grow at a CAGR of 20.33 by 2028. So that means we have a very good prospects or very good chances of increase of these applications of the additive manufacturing. So why we have developed this? In the first system, which was developed by the laser science team and given it to the IIT Hyderabad DRDO cell, which is located in the Hyderabad at Kandi. I am just playing this video, which is actually a video from the IIT Hyderabad, and they have stated here why the technology is being used.
Defined as a process of manufacturing components, usually layer by layer.
The setup we have over here is a 5-axis CNC setup with a laser cladding head, which can be used to generate complex components with materials that are typically considered difficult to form on machine. Now, an inherent characteristic of a process like laser powder DED is the fact that the cooling rates are very high, which could lead to anisotropy, which is why the study of the process structure property relationship is very important, which is one of the objectives being researched in our lab. Now, you could ask, why do we need a process like DD when we have high deposition rate processes like wire arc additive manufacturing? The reason for this is the very small spot dia that we get through a laser, which reduces the globalized heating of the substrate, thus reducing the thermal damage on the substrate as a whole because we get localized heating. Now, this helps us in the repair and refurbishment of very small components such as gas turbine blades. This plays very well into the current industrial demand of green or circular manufacturing, in which we try to increase the lifetime of a product while reducing the environmental impact of the part.
Now, you've seen mostly this video explain the use of the DED in case of the defense sectors and the various repairs of the parts. This is the second system which we have given them few years back, and it is almost a 7-axis with the dual gantry system which we have given it. The height of this laser, which can able to deposit a material up to 3 meter. The width is also almost 3 meter, and the depth is around 2.5 meters. So this is a very, very big size DED first system developed jointly with the IIT Hyderabad, and we also received a patent on this design. This design is itself is used for manufacturing a very high size, which is the parts which are very impossible to build. Conventionally, the people are building these parts, and the specification of the, you can see the size of the cladding material. We have used their -70 to 325 micron mesh type. Powder feed rate, you can see 2.7 to 3.6 kg per hour typically. Laser, we have used a 2 kilowatt lasers. We have used a 2 kilowatt 2 laser system with a beam switch. and the process speed is 0.35 to 4.5 meter per minute. So this is a very high processing speed, and cladding thickness also you can vary from 0.25 to 2 millimeters. So this is a unique first of its kind laser highest size system we have built, and proud to be on the patent of this product. Why we have selected this 2 kilowatt laser is because of the beam quality of the laser of the current laser corporation which we have used is very good. You can see the wavelength is 1070 nanometer, and the beam BPP, the parameter is at almost 150 micron. You can run 6 billy rate. So very high beam quality. Pulse frequency, we can modulate this from CW to 10 kilowatts pulse. Wavelength already 1070 plus minus 10. And we have this is laser, which is a water cooled laser, which is giving a highest power. So this is a multi-mode laser which we have used from Coherent Incorporation. The DD, how this dual DD is work, I'll just play this video, but since the time is limited, I may do some forward of this video. When we have built this system, we have never imagined that this can also able to print a very big part like this size. And when we have seen this actually printed, I am glad to run this video with their IIT Hyderabad's help, that you can able to see how nicely the 1 meter almost inconel 625 powder has been building. And sometimes these systems are running for more than 10 days also. So continuous operation of this laser has been ensured by us while we are designing this system. Also, we have innovative laser program under which we have designed in-house laser cladding head, which is made by our team, and this is a very, very efficient laser cladding head, which is giving you a capture efficiency of almost 80% with the coaxial nozzle. It is a very flexible tool. It has a modular camera there. You can able to view the camera vision system along with this cladding head. Very, very cost effective because there are very low cost items which we have used, and compared to the expensive cladding head, the cost effectiveness is excellent. It is also very user friendly and safe. You can able to install this with the just help of the 4 screw mounted on the Z axis of the plate, and the technical specifications are also given where you can able to select various lenses from f100 to 150, that is a collimator, and you can also select the various focusing options like 150 to 400. This cladding head can withstand the power up to 6 kilowatt laser. Now coming to the application which everyone who are participated in the defense are more keen on to know what are the various defense application which we are going to present today. So the first is the turbine blade. So you can see the turbine blade when it is corroded at the edge. The nickel-based super alloys can be used to repair this, and you can see after repair almost similar as good as new turbine blade has been built. So this is one of the major application where we can save a lot of money by using repair of an turbine blade. Then the company HAL is very popular and they are using this laser sintering DMLS method to print the turbofan engine 25. Now this additive manufacturing is enable HAL to accelerate the production of the high pressure turbine blade, which would take around 2 years using the computer system. Like if I build that with the CNC machining or a CNC system, it would have taken almost 2 years to such a complex turbofan engine. So HAL DMLS was one of the used by their design to achieve the quick turnaround of the intricate parts. So this is one of the example why people are in defense industry using DMLS technology. Another company of the US is called General Lattice, where US Army is using signing and contract with a 3D design software company, basically to improve the impact absorption of the Army's combat helmet using a 3D printing and the advanced lattice geometry. So you can see the complexity of the helmet is used, where you can see it's a hollow helmet, which is a very lightweight because for the combat operation, the helmet weight is very important. But when we reduce the helmet weight, the toughness of the helmet should not be compromised. So that is what they have ensured using this DED technology, the printing of the helmet design. Next is the Austrian Army, which is using a speed 3D model of the DED in the field. Now, why they want on the field? Because if there is an army, there will be a this deserts or any complex area where this machine is installed, where suppose the armor tank is not working and you need to repair this tank cover or any wheel cover immediately using this DD technology, then it is now possible. So you can see this with the video
with the Australian Army,
how this
the training of the
armor
Army's
tank has
first
been built.
additive manufacturing cell team. This team specialised in the production training area located in the Northern Territory. The additive manufacturing cell team has been putting the warp speed tactical printer to its toughest trial yet. The printer was transported over 600 kilometres and has been operated. It's been used by the Australian Army for over 40 years. The team was also able to redesign the part, increasing its strength to reduce the likelihood of future damage. This part was printed in less than half an hour. Demonstrated how it can help to sustain the working condition of armoured vehicles and how additive manufacturing can play an important part in the future of defence readiness.
So you can see within 29 minutes, this part is ready and the job is done. So this is one of the fastest 3D printer, which is giving you the best result. Now, NASA is already engaged in developing a channel wall nozzle. Now, this is CWN fabrication with the multiple programs over the last few decades. The NASA has been advancing the powder bed fusion additive manufacturing for chambers and nozzles. So this is very proven system now, additive manufacturing for these kind of application where a CWN nozzle walls need to be printed. Also, this ships and propeller made with an additive manufacturing. Now you can see this naval group in France. They are using a 3D printing for various application. One of is to print this huge size of the propeller using a wire arc additive manufacturing process. Now, propeller consists of the 200 kg of the blades, which is fitted to Andromeda, a mine hunting ship. Now, these kind of ships are of huge size. So you can able to see this almost the ship propeller size is almost around few meter of around 5 to 10 meter size. So this can be printed using a wire arc method. Boeing patents the 3D printed aircraft parts. Now there are so many parts, tiny parts, metal parts, non-metal parts are required in combat aircraft, and the Boeing is using already almost 150 parts in F-16 or F-18 super harvest forward fuselage are used by using a 3D printed. 3D printing reduces need of the stock peeling parts and minimize the research usage. Because any kind of these parts are, if it is required within a no time, the 3D printing can able to print. So you are keeping your inventory also as low as possible. US Navy is the first 3D printed missile component. Now, this is also something uniquely first time the US Navy has used the additive manufacturing to print a missile parts, which is a connector back shell into his missile system. Digital 3D printing process reduces the production time by half. This is the very important factor of additive manufacturing. And compared to traditional, it will give you a very good advantages. Parts use are protect the cable connectors in the missile system and made from the aluminum alloy. So the weight of the part is also reduced by several times using aluminum alloy. So this is also a very important factor why people are using additive manufacturing defense. Advancement in rocket technology, SpaceX. Now, SpaceX is a company owned by this Elon Musk, and there are a lot of spaceships he is building using this additive manufacturing method. The first time the 3D printed thrust chamber was used to rocket ignition. And SpaceX continue to refine this Super Draco engine with the additive manufacturing technology. Super Draco chamber made using a DMLS method from a 3D printing, an inconel powder, a nickel-based powder with a high-performance super alloy for strength and toughness and its reliability. So most of the this rocket technologies parts has been made of using nickel alloy, which is inconel, and other for higher toughness. Now, if you come to the SLM, that is selective laser manufacturing system, parts produced by the additive manufacturing are like combustion chambers. You can produce an metallic material like aluminum alloy rim. Then when we talk about the medical application, human heart prototype are now being printed. A dental implant is already very popular using SLM method. Impeller repairing also can be done. This is the human skull, which is used for the study in case of the research in medical application. And some of the non-metals are used for decorative application. So this is in general the various application which covers entire area of the usage of SLM technology. Now, if you see the bioprinting technology method, why people want to print various complex bioprint tissues, like creating a tissue and an organ. So this is a rapid growing market, which is right now a lot of research are going on rapid growth of bioprinting technology. This enable a creation of complex 3D structure using living cell and bioinks. So these are now companies, there are various companies involved in manufacturing of various material like stem cell, tissues, organ-specific bioinks suitable for the human use, reduces the dependency of the organ donors and possibility to regenerate the replace the damaged organs and the tissues. So this technology, no one has think on that it can also can be used for printing such complex human organs. So we are now mainly focusing today on the 3D metal printer because most of our industrial customers are asking for a 3D SLM type of selective laser melting process of a 3D metal printer. So we have designed this using a 300-watt laser with 200 micron to 600 micron layer thickness. You can able to print, and these are the brief specification of the system. Now, salient feature is this is very compact. You can see this is a very user-friendly single touch HMI has been made, and at the front door you can able to load the powder very easily. I don't have the complete video of this system, but I'll just play because of the time the basic video, which is just give you a fair idea how it is going to work. So you can see the Galvo scanner is moving at all the places for printing the various parts as per the design, which is fed. So first layer is already has been powder has been spreaded and the laser has been printing. After that, finishing the first layer, the recoater will start moving and it will start printing the next part. So this is completing the outer border of the parts. Now the recoater goes to the back to collect the powder again, and it will start spreading the powder, the second layer. Now again the laser will start moving. You can see the powder bed has moved up little bit, and then the laser has been started. So this is how the selective laser melting printer is work. Today, why we are talking about the medical application also along with the defense, because you can see there is a printing revenues chart which is giving us a enhancement for forcing towards various medical application. So you can see the orthodontic insulates are there, orthodontic braces, prostheses, audiologist devices. So there is a day by day from 2021 to 2025. You can see the chart is growing, and the revenue generation up to 25 or end of the 26 is crossing around 680 US million dollar. So this is what enhancing us, and everyone is going to use this technology very widely. The projected market value of the selected 3D printing, if you consider various material, various services, various softwares, so you can see in hardware industry, in the materials and the service industry, and with the software, the revenue generation is going to increase day by day up to almost 67.17 US million dollar. What are the various implants which is going to manufacture using the additive manufacturing? So one of the key requirement has come. Most of the people are aware about various pictures which I am showing here. This is the prosthesis, cap, and various orthopedic implants are shown. But when you need a just-in-time implant, like suppose the accident has happened and you want to do the specific parts to be printed immediately, Lima Corporate recently installed a very first production facility within a hospital. Now, this is something unique concept which New York City's hospital has started, and a special surgeries starting a new era of additive orthopedics. So this is called a just-in-time implants, a joint project between the Australian government and RMIT University in Melbourne and the University of Technology in Sydney also started with this, and Vincent Hospital in the Melbourne is also started this kind of technology to install in the hospital, where immediately a 3D implants can be printed for the orthopedic application and it can be fitted as per the customized requirement. 3D printing titanium hip ball and the socket. This is a very common problem in the old ages of the Indian and the other European countries and African countries. The hip ball movement is getting weakened or it is getting broken due to the various reasons, and this can be easily printed as per the customization, because most of the time the customization demands the specific size of the hip ball and the socket. When we talk about the dental industry, in the medical market, the dental market goes through a very dynamic and shift from a handcraft work to a fully digital. So you can see in the left hand side, the traditional workflow chart has been shown, where you can see the aligner is being made first, the impression, you take it. If you visit a doctor, it will need at least 3 to 4 visit minimum to manufacture one plaster model, and then he will send this plaster model to lab, and then after lab the design and casting will be done, and manually some worker will able to finish this product, and after that once you receive from the lab, again your doctor is going to call you to deliver and to fit into your uh, as per the requirement. So this is a very complex, tedious process has been replaced with the digital workflow. Now digital scanners are available. It will scan your teeth wherever it is broken or wherever the changes of the caps is required. It will be designed immediately using a software, and immediately this transferred to 3D printing, and the cap is ready and it can be fitted to as per the requirement of the patient. Now, this market is also growing. Like if you see the only equipment market, it is going the CAGR of 4.4%. But when you see the dental implants, it is going at a CAGR of almost 28%. So these are the various caps and the various dentures where the application of the 3D printing has been widely used. There are at least in India, this market is growing at a very high rate. And most of the people are now preferring to use a 3D printing implant compared to the conventional method implant. So if we give you a simple example of the caps, now I have this data from little old slides which we used to present when we are planning to introduce this laser 3D printing few years back. So it is shown in the euro, but if you consider in the rupees also, it will almost going to, as per the understanding, remain the same. So now you want to print number of caps. Now, if you see, if suppose you are using a small number of caps, like 528 or 1,000 number of caps, your profit ratio is low. So the chance of your getting the net profit increases only when you are using a very high rate of manufacturing this kind of caps in a day. So this analysis is showing more number of caps we are making, the more number of the profits you can able to find. Now there are contribution of the fixed cost and the variable cost. Now there are variable costs are also involved in this, and the fixed cost is there, which is called a capital cost or the powder cost. So direct material cost is around 79% and the variable cost is around 18%. And you talk about the analysis of these caps, return on investment. I have this given this to just give an idea to all the people, whether it is into dental or into any other application of the orthopedic also, because this capital cost or the powder cost going to remain the same. Whereas the application by application, only variable cost is going to change, depend upon the type of the application. So you can see the sales, if you see figure of the price, the total sales is around 42,240, where they have assumed, there are some assumption also made on the right hand side, for which we have used the based on the production of 24 units per day and running the 3 batches. So that is the reason why these figures are coming. So if you see the break even at 15 caps per day. So if you are only manufacturing the 15 caps per day, still you will get a break even. A macro lab capacity equal to 30 lab. Like suppose you have a lab which is having 30 caps per day, your ROI return is higher. And suppose you are doing it at a very high rate, like you are making a 240 caps a day, then your ROI is just you will get within a less than 3 months time. So such a fast ROI you will never get in any other industry or using any other technology. These kind of returns of the investment is not possible. Day by day, the caps usage in India and abroad and all of the technology users are using only the additive manufacturing caps, because people are not having much time to get it replaced, and this technology is going to increase more and more number of the machines demand. Similarly, this is the telescopic bar, the entire denture which is need to be printed, where the cost of the profit is also more number of this kind of telescopic bar printed, the profit is going to increase more. You can see here the ROI return is almost with the full capacity, you will able to return this ROI, return of investment, in less than 2 months. So even if when I have done some assumption on the right side that my laser system is say 110,000 euro, a capital cost of the system, and if I use a chromium cobalt powder which is around 200 rupees a kg, still my investment on the return can be reduced within less than 2 months if I able to print almost 528 caps, and still my profit ratio is as good as you can see. The gross margin is around 441,16909. That is a gross margin, and my net profit is almost almost 4 lakh euros. So this is what kind of the profit of margin you will able to receive in case of this dental application. And with this, I would like to end my this session. Thank you very much. Now, if anyone is having any questions, please raise the hand, or you can also call me directly on this link. Any questions, sir, from anyone?
Manoj, I have a question, please.
Yeah.
So, whatever you spoke about is the aerospace and the medical industry, but I think this is also going to be very vital in the precision engineering. Is it already picked up, or is it still lagging on the precision engineering departments?
No, it is picked up. There are at least south part of the India, you can see there are more than 15 to 20 laser job shop are already using this DMLS technology and DED technology for aerospace and defense. Around HAL, there are at least 5 to 6 player. The biggest player is today is the Wipro, who is installed more than 6 of this kind of DMLS system, and mostly serving the aerospace and defense industry. In Hyderabad also, there are 4 to 5 laser job shops are available using this DMLS and DED technology.
Okay, okay. So the scope is looking really fertile.
Yes, yes,
Yeah.
yes, yes.
Okay. Thanks, Manoj. Yeah.
Thank you. Anyone else, sir? Anybody would like to ask any question on various application or any on the system?
Okay. Since nobody's asking another question, I thought I'll ask one more question. Usually
Okay.
the post processing is usually takes more time in a 3D printing. This is what I heard from one of the doctors. Is it true?
Post-processing selection of the equipment is very important. Most of the time, people are using the conventional technology for post-processing. Like when we have supplied this direct energy deposition system to IIT Hyderabad, we have also installed, which I have not shown in my video, a robotic arm with the tool, which is immediately processing this big size 3D printed parts. Immediately, the 3D printed parts are finished. The robotic tools automatically it will go as per the program to the various holes or various complex areas. Since it is a robotic arm, it can go very easily, and it gives you a polishing surface very fast. Now the same method you can able to remove these parts by cutting from the substrate from the base, and again fitted these parts on a lathe machine or on a milling machine. So that is going to give you a very time consuming. So selection of the post processing procedure or the tools is also very important.
Okay, okay, got it. Thank you.
Okay, Manojji, I have one simple question.
Yes, sir.
Suppose somebody want to order this kind of system. So what may be the lead time? Like how much time we can able to make it?
The lead time depends upon the size of the DED system in case of the DED, and the standard lead time you can say around 3 to 4 months for any specific small size of 500 by 500 millimeter size DED system. So 3 to 4 months is the lead time for delivering this equipment, and same is with the DMLS.
Okay, okay. Thank you, thank you.
Thank you. Anyone else like to ask some question? You can text on the text box also if it is a. So with this, I would like to ask Aditi to declare this webinar is, we are stopping this presentation. So over to Aditi.
Yeah. Madam, I have a question. Yeah, regarding the
Thank you, Aditi. Thank you very much, Manoj. Yeah, bye bye.